Hi, good morning, everyone. Welcome to this program. And today we are going to look at, we're going to dive into the introduction to circuit designs. So at the end of this course, you're going to understand how to design circuits and circuit simulations, and you get to know other softwares you can use for this. So I'm by name Abdulrahman Abdullah. I'm a Prompto team member, and I'll be taking you through for the 5 days training. So okay, so let's start with our course. So what do we mean by circuits? So a circuit is just a closed loop or a pathway through which electric current flows. Uh, you can imagine, or you can try to understand a circuit as a form of a closed loop, which uses like Kirchhoff laws, Ohm's laws, other stuff like that to for the flow to explain the flow of current. So a circuit is just a closed or a pathway through which current flows throughout throughout. So here there's a battery, which is an energy, which is the electrical energy that's supplying the current to this load, to this bulb. So the current comes from the negative side and enters and flow through the load, and with that is going to come back again, enters this plus the positive terminal, come out again. So this is how it continues throughout until the energy source, which is the battery, is being removed or switched off. So a circuit is just like an interconnected components where we have components like resistors, capacitors, inductors, diodes, transistors, integrated circuits connected together. So each of these components has an effect on the flow of currents. Like we have some components that are passive, such as resistors, capacitors, inductors. So these are passive components which has effect on the flow of current. Like resistor limits the flow of current, capacitor stores electrical charge and all in an electric field, while inductor stores it in a magnetic field. So there are active components such as semiconductor devices or components like diodes, like transistors, like integrated circuits. So each of these components as well has effects or controls the flow of current. Like diode, there are different types of diode. Uh, Taking a PN junction diode as an example. So this is a kind of diode that allows the current to flow in only one direction. So not to talk of transistors, not to talk of uh, um, not to talk of integrated circuits, the ICs, the microcontrollers. So a circuit could be a simple circuit or a complex circuit. It depends on the number of components in the circuit. So how does a circuit moves, or how does a circuit work? So let's look at this in order. Electricity flows in a circuit uh, due to the movement of charged particles from the energy source, which is the battery. Uh, so this charged particle is electron that flows from one point from the output source to the loads and to the input source as well. So this electrons carries is a charged particle which carries a negative charge. And these charges are thus repelled from the negative terminal of the battery or any other energy sources. And these kinds of charges do some kinds of are attracted by positive terminal. So while this electron flows out from the negative terminal, it gets to the load and comes out as well. Then this will be attracted by the positive terminal as well, because according to the law of electrostatic induction, like charges repel and unlike charges attract. So there will be a force of attraction between the negative and the positive terminal. So like you can see, we have two cells here, the positive, negative here. And these two cells are connected together in a series where we have negative and positive connected together. And positive side here and the negative side becomes the output and input source. Electrons is very important. Without electron, the circuit will be a dead circuit. And before electron will flow through a circuit, there must be an energy source, which is an electrical energy source, be it battery, power supply, and all those stuff like that. These components, any component that has been connected to these circuits, like the resistor, has an influence in the flow of electrons. There are other components like voltage regulator, like Zener diode, and other stuff like that, which regulates, and yeah, they serve as voltage regulator and stores like capacitor and inductor that stores charges in both electrical and magnetic fields. And there are other components that amplifies electrical energy, such as a transistor and ICs as well. A transistor can work as an amplifier or as a switch. Yeah, the path electrons take depends or affected by the component characteristics and the kinds of connection. Like resistor can be connected in different ways, such as a capacitor as well. So the movement of electron are being influenced by all these components, be it passive and active component. So like I was saying, we have there are two components, types of electrical or electronic components. There are passive components and active components. Active components like resistor, capacitor, inductors, and all that. Active component or resistor restricts or offers limitations to the flow of current, and it can be used as a voltage regulator, the voltage control, current limitations, and signal level adjustment. Yeah, a resistor can also be used for voltage as a voltage divider, as a voltage multiplier, this stuff like that. So the same thing, another another passive component is the capacitor, which stores electrical charge or electrical energy in an electric field. So capacitor can be used as a filtering agent or signal filtering, especially in the step down or step up transformers or conversion from AC to DC. Capacitor is very important because capacitor is used to filter the ripples, filter the AC ripples. So capacitor is very important in AC signal transmissions and voltage stabilization as well. So there are other passive components like an inductor, which stores electrical charge in a magnetic field. Yeah, it has a lot of applications, especially in filtering as well and impedance matching. So we have other type of electronic components, which is the active component. So active components like diodes, transistors, and relay circuits are very important. So let's look at the active components. Let's look at active components like a diode. A diode is a semiconductor devices which serve as an active component that controls the flow of current, especially the PN junction diode that controls the flow of current in only one direction, while blocking the current in the opposite direction. Take for instance, there are positive and negative terminal of a diode. So if the positive terminal is connected to the positive terminal of a battery, it will allow the positive the current to flow through itself and have an effect in the flow of current. That means it will allow the current to flow in only one direction. And from the negative terminal of the diode, the current will not be able to come back again. So it will block it if the current will have to come back from the other direction or opposite direction. So diode is very important in rectification and signal demodulation, yeah, and voltage regulation as well. So transistors are semiconductor devices that serve as an active component as well, with transistors as three terminals, the collector, the base, and the emitter. So a transistor can be used as an amplifier and also as a switch, or yeah, as an electronic switch. They are fundamental building blocks of any electronic circuits. They can be used in amplifying circuits. It can be used in oscillatory circuits as a digital logic circuit. So the other one is integrated circuits, ICs, which contains multiple semiconductor components like transistors, diodes, resistors, and all these are joined together or connected together on a single chip. So they are complex circuits. They are ICs as well as circuits on their own, which they have wide range of applications. Like ICs are used in microprocessors, in microcontrollers, and communication devices. So these are the two important types of electronic components. So let's look at, so this is a pictorial form of each of the components I mentioned earlier. So there is PN junction diode, the light emitting diodes, infrared LEDs, Zener diodes, photodiodes, Sosky diodes, a lot of diodes are having. So the same thing for resistors, all these active components, you can see there are ICs, there are different type of diodes there. So yeah, let's look at each of these. Let's look at some of these components. Like a resistor. Resistor is a passive electronic component which controls or offers limitations to the flow of electric current in a circuit. A resistor opposes the flow of current, as you can see, meaning it converts due to the limitations or how it offers opposition to the flow of current, then definitely the same electrical energy in the circuit will induce what is known as heat energy. So resistors are very important. Almost every circuit or every circuit has a resistor because it can be used or to limit the flow of current in the circuits, and they can be used as voltage dividers as well. What do I mean by voltage dividers? Let's say you need like 5 volts in a circuit, then there's an income, maybe the input is 12 volts, then you want to divide the voltage. So there are some kinds of ways of connecting resistors together to serve as a voltage divider. So resistors are also used as a bias point or in a bias point, especially when they are connected to the base of the transistor. So resistors are very important in electronic circuits. As you can see here, these are the two symbols of resistor. Fixed resistor, say. So this, if you see any of this in a circuit, this or this, it's definitely a resistor. So this is a pictorial form of a resistor. Yeah, these are resistor looks like. There are different types of resistors that look like this. There are 4 bands, 5 bands, 6 band resistors, and each of these are having different colors, which are called the color codes of a resistor. So there are different or common types of resistor, the carbon composition resistors, which are made from the mixture of a carbon dust or a graphite. There are other types of resistors, although these carbon composition resistors are used as a general purpose applications in offering limitations to the flow of current as a voltage dividers, as timing circuits for 5F timers and other op-amp like that. So there are other types of resistors like metal film resistors, which are made from the deposition of a thin film of metals onto a ceramic rod. So these are the ways this is the way the metal film resistors are being constructed, and they have very importance, especially when they are used in and especially when you want to apply them in precision, or they can be used in instrumentations, in constructing instruments, as in audio equipment. So other types of resistors are wire-wound resistors, which resistors are made from winding a resistive wires around a ceramic core. And these kinds of resistors are very important because they have high power ratings, and they can be used in motor control circuits, in high frequency applications, and other stuff. So that another type of resistor, which is thick film resistor, which are produced by depositing a resistive paste in onto ceramic substrate. And these are due to the form, or due to the form of production, they do induce high temperatures like that because they're made from thick films. So they are cost-effective resistors, and they are used in all these consumer electronics. The one we use at home, in cell phones, in laptops, and other consumer electronics. They are used in automotive electronics, and they are used in mechatronics devices as well, like drones, like robots and those stuff. Other type of resistor are variable resistors, which has an adjustment. So variable resistor, from the word variable, they are resistors that can be adjusted, like they can be set to zero resistance and can be set up to the value. It depends on the value of the resistors. There are 10K variable resistors, 50K, 50,000 variable resistors, 50,000 ohms variable resistors, all those stuff like that. And they are very important in voltage division and voltage control, and current control as well. So the other types of components you're having is a capacitor. The capacitor is also a passive electronic component which stores electrical energy in an electric field. So a capacitor are separated by insulating materials, which are called dielectric materials, and they are widely used in electronic circuits for energy storage, for voltage regulations, and timing applications. So this is a circuit symbol. These are circuit symbol for a capacitor. This circuit symbol is different from this. This is for a non-polarized capacitor, meaning it doesn't have positive or negative. And this is for a polarized resistor, which is a kind of resistor that has both positive and negative sides. And this is an example of a polarized resistor, which are called electrolytic, a polarized capacitor, which are called electrolytic capacitor. They have both negative and positive sides, and each of these terminals are separated by a material called a dielectric. So there are different types of capacitor, like I mentioned initially. There's an electrolytic capacitor, which is a polarized capacitor having both positive and negative terminals, and they are commonly used in power supply filtering, in audio amplifications, and other electronic devices. So other types of capacitors are having ceramic capacitors, which are very small size capacitor, which offer a kind of low inductance and high frequency. They are used in timing circuits, and they are used in communications as well. Another type is tantalum capacitors, which have high capacitance density and a kinds of low leakage current. They are used in portable electronic devices, in telecommunications, and medical devices. Other types are having a film capacitors, which are made from thin plastic film, and These thin plastic film are used as the dielectric materials, and each of these types of capacitors are used in audio circuits, in power factor correction, and high frequency filtering applications. So other type of capacitor we are having are polymer capacitors, which uses a conductive polymers as electrolytes, and they have the applications in voltage regulations, in digital circuits in the code name. And as we have variable resistors, there are variable capacitors as well, which are adjustable capacitance values, and they are used in tuning circuits like radio receivers, radio frequencies. They are used in oscillation or oscillatory circuits. So these are the types of a capacitor. And looking at inductor, yes, inductor is another type of a passive electronic component that stores electrical energy in the form of a magnetic field. Yeah. So an inductor consists of a coil of wire wound around a core. As you can see in this picture, uh, this wire is an aluminum wire, and this is wound around a core. And yeah, they are made, these kinds of materials are made from ferromagnetic materials, the core, which are made, the inductors or the wires are wound around. So each of these windings has the voltage, as the resistance, and each of these windings, counting from the starting point to end, uh, constitutes a kind of voltage, which is electromotive force. Yeah, so the beginning, which is 0 volt. So at the end, there will be a certain value for it, which will be the output voltage of the windings. It depends on the number of windings here, and these materials are very important, especially in the applications of things like AM, FM receivers, transmission circuits, auxiliary circuits. So they are very important as well. So these inductors are measured in a unit called henries, which is this. So this is a circuit symbol inductor, and this is a picture of an inductor, the pictorial symbol of an inductor. So looking at semiconductor devices, which are active components, basically made from silicon materials, germanium elements, and yeah, so a semiconductor material could be seen as a material where could be seen, yeah, to a layman, a semiconductor material could be seen as a material that stands in between a conductor and an insulator. So a semiconductor could be seen as either an intrinsic or made from an intrinsic or extrinsic materials, meaning adding both two elements together, elements from group 5 and group 3, doping and other stuff like that. So semiconductor materials are very important in electronics, in consumer electronics, in automotive, in mechatronics. So there are basically two fundamental semiconductor types or devices types, which are diodes and transistors. Looking at a diode allows the flow of currents in only one direction while blocking the current in the opposite direction. So a diode consists of a semiconductor material which constitutes two terminals for each, the anode and the cathode. So let's look at the operation of a diode. So for a diode, okay, looking at the circuit symbol of a diode, the anode and the cathode, when a positive voltage is applied to the anode of of a diode. So the diode, we conduct the current, we conduct the flow of the current, so allowing the electrons in the current to flow from the anode to the cathode. And this same current that flows from the anode to the cathode will not be allowed to come back from the cathode to the anode again, unless if the energy source is connected in a reverse bias. So there are two types of connecting a diode in a circuit. It's either a forward bias connection or a reverse bias connection. So in a reverse bias connection, the cathode is more positive than the anode, and this will constitute the diode to block the flow of currents. So the difference or the meaning of biasing, or be it forward or back reverse bias, is that so in a forward bias, the diode will work as it is expected, meaning the diode, the anode will be connected to the positive terminal and the cathode to the negative terminal, and this will allow the diode to work as it is expected, meaning it will work as a device that allows the flow of current in only one direction. But in a reverse bias, meaning there is a changing of the energy terminals between the cathode and the anode. The cathode is connected to the positive terminal and the anode is connected to the negative terminal. And this makes the diode to serve as a blockage device, which will not allow the current to flow from this direction. So diode, there are different types of diode, like there are p-n junction diodes, Zener diodes, photodiodes, Schottky diodes, and other types of diodes like that. And each of these diodes has their applications, like p-n junction diode are being used to allow current flows in only one direction, and photodiode, or I should say, Zener diodes can be used as voltage regulation, fusion regulation, yeah. And a Zener diode are connected in reverse biased and not forward biased. So the other types of semiconductor devices are a transistor. So transistors are semiconductor devices that can be used as an amplifier or as a switch to switch the electronic signals or to amplify the electronic signals. So there are three layers of a transistor: the emitter, the base, and the collector. And looking at the emitter are generally connected to the negative terminal of the battery or the energy source, and base serve as a controller which controls the current from the emitter to the collector, and collector is the output of a transistor. And so, although there are different types of a transistor, there is bipolar junction transistors, which are called the BJTs. There are field effect transistors, which are called effects. There are MOSFET, which are metallic oxide field effect transistors. And there are IGBT, which is insulated gates bipolar junctions, bipolar transistors. So there are different types of transistors, and each of them has their own applications. So for a BJT transistor, they control current flow using both their electrons and the holes. So we have the P and the N. So which are the poles and the holes, the electrons and the holes. Although transistors has a principle of operations whereby electrons move from one layer, which is from the valence layer to the conduction bands. So, and this flow of currents will be constituted by the energy source. Without the energy source, there won't be a flow of currents from the valence band to the conduction band. Also, like I said, a transistor has three conducting layers, which are the emitter. Emitter is the arrow. This is the side of an emitter, which is the arrow part of, which has the arrow parts in the circuit symbol. And this is the collector which serves as output, and this is the base which serves as a controller. So a transistor, a BJT transistor can be seen with different types. There are PNP, there are NPN transistors like BC507, BC508, and other types of a transistor. So and the FETs, they have high amplifying signal, and they have high power, and they are used in inverters, in UPS. There are other types of FETs, which is a MOSFET, metallic oxide feed effect transistors, and there are other types of a transistor, which is IGBT, which is insulated gate bipolar transistors. So the next thing we are going to move on to is understanding circuit diagram. A circuit diagram can also be called a schematic diagram, which are a form of graphical representations of an electric circuit using the symbols of the components, or using the symbols to depict each of the components and how they are connected within the circuit. So that's what a circuit diagram is, like a graphical representations in which all components that are connected that are connected in the circuits are represented by the circuit symbols, like a resistor being represented with the circuit symbol, and capacitor, and batteries, and all the other components like that. So these are important components of a circuit diagram. We have important components of a circuit diagram, which is the connections. Connections are wires that are being shown in the circuits, which serve as a connector between each component. Like let's say you want to connect a resistor to a diode. So the points or the line that is drawn, that is connected from one terminal of a resistor to the terminal of a diode is known as a connector, which are lines or wires that are being used to connect each of the components. And the other component of a circuit diagram is the symbols, or are the symbols. The symbols are used in circuit diagrams, which the symbols that are used as standardized symbols that are used in electronic industries, embedded systems industries, to represent each of the electronic components. And each symbols are very important. If you miss any of the symbols, meaning you made a mistake to connect a component which is not represented by the circuit symbol you used. If you do that, it's going to have an effect on the flow of current in the circuit, or it can turn the circuit to another thing entirely, maybe affect the circuit or burn the circuit. So the circuit symbols are very important for each component. So the other component of a circuit diagram is the hierarchy, which are kinds of illustrations that are used to depict the basic circuits to a complex circuit diagrams. And the hierarchy is just like how each component are being labeled or are being connected with other components, meaning each circuit diagrams start with a simple connection until each of the components are connected together, and this we make it to be like a complex diagram. So annotations and labelings, these are very important part of a circuit diagram. Yeah, labeling is, let's say you connected a resistor to a circuit, a resistor are known as R, or are labeled as R in the circuit. So if you miss this information, it's going to have an effect in how others understand the circuits diagram. Labeling adding values to each component are very important in a circuit diagram, and all of these are components that define a circuit diagram. So looking at other stuff here is the type of circuit diagrams. There are different types of circuit diagrams, schematic diagrams, the wiring diagrams, and the block diagrams. For schematic diagrams, it provides a detailed representation of each component in the circuit and how they are connected within the circuit. So schematic diagrams are used to illustrate the electrical connections between each component within the circuit. This is a component, this is a component, this is a component, and all these are components. So the schematic diagram will illustrate how each component are connected within a circuit. So looking at the wiring diagrams, the wiring diagrams are very important, which most of the circuits are designed using wiring diagrams or the combination of schematic and wiring diagrams. So for a wiring diagrams, the focus is to illustrate how each component are connected using the lines, how they are the layout of each component, how each component are connected together. So wiring diagrams are more detailed than the schematic diagrams because they show the layout of each component and how the wires are connected together. How the wires are used to connect each component. So looking at the block diagrams are just illustrating each component or each stages or each stage of a circuit diagram with a block. Let's say you are designing an inverter or an inverting circuit. For an inverter, there are different stages like the power stage, the oscillator circuits, the amplifying circuits, the output circuits, the low battery circuits, the low battery cutoff circuits, the high current circuits, all those stuff like that. So instead of you to like draw or design these with a schematic diagrams, we should make it look like a complex diagram. So you can use a block diagram to define or design the circuits. Like, okay, let's say this is a power supply, this is oscillator circuit, this is amplifying circuit, this is a monitoring circuit, which is low battery cutoff, high currents, high voltage, and all those stuff like that, and the output circuits. So these are the different types of a circuit diagram. So we are going to the end of today's class, which is on so lastly we'll be looking at softwares that could be used to design electronic circuits, and these same softwares that can be used to simulate them. The SPICE simulation program with integrated circuit emphasis. There's Multisim by National Instruments, the Altium Designer, Cadence, OrCAD, the KiCad, the Eagle PCB, the Proteus, FreightZine, and other softwares can be used to design circuits, diagram, and also simulate its circuits. During the course of this training, we are going to be making use of an Eagle software to design and simulate circuits. Although Eagle make use of applications of SPICE, which is NG SPICE, to simulate a circuit diagram. So lastly, thank you so much for joining us today. I hope you all understand what is being explained today. And I believe at the end of this training, you'll have a lot of insight about designing the circuits, and you'll be well informed in making decisions on how to simulate the circuits using the ngSpice simulation in Eagle software. So you're expected before the next class to download Eagle software. You can download these from Autodesk website. So go to Autodesk website, find Ego and download it for the operating systems you're using. They have for Windows, they have for Linux, they have for Mac, so you can get to download that. So thank you. Yeah, if you have any questions, you can ask. And thank you so much. We meet next time.